So in today's video, I have this tree structure up here in Python, and we have this tree function that returns a label and a list of branches. We have label, which returns label of a node in our tree, and then we have branches, and then we have a check if there's a tree. There's a check if this is a leaf, or in other words, at the very bottom of a tree, there's nothing below it. And we're going to be implementing this height function. So let's go ahead and take a look at a sketch of one. So I have right here this tree, and we've got quite a few branches and children. And we have, to the side, I've drawn this bracket with an H next to it just to represent how I have a height. And the goal of this problem is to figure out how tall it is. So, or in other words, maybe how you could also think of how many levels from the starting. So we have this start node, which has 2 children. And so that would be 2 levels, counting the start, and then the 2 children. And then the first child, 1, I'm just marking as 1, has then let's say 3 and 4 as a child. And 4 has this child of 5, and 3 and 4 would be considered leaf nodes because there's nothing below them or connected to them underneath. And so if we look at the other side, we have we have 2, and we also have, we'll just say it has child 6, and we have 7. And if we look at this overall height, we have this path that goes from S to, which is my start, to 1 to 4, then to 5, and that's the longest child down. And that also means it has the longest height, or the largest height, I should say. And so this is going to be 4 nodes downwards, or 4 levels of nodes, I should say. So we have 1, 2, 3, 4. And then this function that we have height that I'm going to talk about we're going to be wanting to get that number 4. So let's go ahead and go back to the code. All right, here we have return the height of tree, and then we have some sample. And so the first thing that I'm going to do is just to make a note to myself to remember to do a base case, or base cases. And then I need some sort of then recursive code. Let's see it. There we go. I can spell recursive call. And so if we think about the way up here we've implemented this tree, and we have tree with the label and then a list of branches, and then each branch in here is going to be some sort of tree as well. If we look right here with this example under height, we have t equals tree, and then we have a 3, then we have some brackets to show a branch, and then we have this other tree 5, and then we have tree 2. And then underneath tree 5 specifically, we have just tree 1. And so that's how we're going to represent every single node. And so because of this, we need to consider what is the smallest possible thing that this object tree, as we are treating it, is going to be. And so if we think about back to our picture, the smallest node is going to be a leaf node. And we do have this function here that checks if it's a leaf, because leaf means there's nothing below it. So that's what I'm going to use as my base case. So I'm going to make a comment to myself and be like, if it's a leaf, then return. And we're done. There's that. And then if I don't have that, what do I want to do? So remember, my goal is to figure out what the heights are. And so I need to be able to go through every single branch and figure out which one ends up being the longest, in a sense. And so we need to figure out how to loop through every single one of those branches. And we know that branches, it's going to be implemented here. If we look at this, as a list of trees. And so here we have this tree, and we have this tree, and then we return this list of them. And so I would like to go through every single branch and look at every single node within that branch. So if that's a list, I can just say, so for, let's say, branch, and then, let's see, I think the function was branches. And then I'm going to pass in T, because that's a tree, so I want to look at the branches of T. And then the next thing I want to do, looking at that, let's see, so I need to look at the height of every single branch, or in a sense, you could think of it as the height of every subtree. And actually, let's go ahead and go back to the drawing and take a look at what that means. So I have this back to our drawing, and then I'm just going to erase these numbers. So if I want to look at the height, I could think of the problem looking at, let's say, one path. I'm just going to choose this one since this is going to be our longest. So we have 5, 1, 4, 5, S, 1, 4, 5. And then to look, when I do my recursive call, I'm going to be looking at each branch. So then what I'm going to do actually is I'm going to kind of cut off that start, and then I'm going to look at this style of tree, which is that 1, 4, 5. And then when I look at that branch of then tree 1, since this is going to be a recursive function, then I'm actually going to be looking at this tree 4 and 5. And then I'm going to look again and then just look at then that tree 5 and say, oh wait, it's a node. It's a leaf. And so then I'm going to stop. And so that's going to be where I'm stopping. We're going to take all those, the height of this leaf node, and then I'm going to be adding that on top of then whatever to help me create all the other heights of the other subtrees I'm creating. So when I return, so I have the height of 5, I'm going to need to somehow like add it to then the height of, to help me create the height of like 4, 5, and then to add again to be the height of then 5, and then 1, 4, 5, and then again back to the start. And so that's how I can think of me recursing all the way down, then getting some height, and then coming back up and then giving it back. And so if we just have a leaf node, then we need to think about, okay, so then what is our height? And then also, how do we want to connect all these heights? So when I'm returning, I'm going to figure out what that value is. So let's go back to the code. And here, so we have if leaf return, and then you're done. And then I'm actually just going to say, so we want to return probably some number. And it's probably going to be the height of one node. So if that's the tree, then that's the height that we want to give. And then, so then for the recursive call then, what do we need to figure out then that height. So I'm just going to go ahead and call height in here. And then we'll pass in that branch. And then the question is, then what do I want to do next? So I think something that we can do, since each branch is going to have its own height. So if you think about that drawing again, there was one path that was super long, longer than everything else. But then other paths were shorter. So what we're looking for is the longest height. And so I need to find a way. So when I'm done to return that, so maybe what I can do when I'm done is say something like, let's say, return like longest of all the branch heights. Okay. So I think for pseudocode, I think it looks pretty good. And so now the next thing I'm gonna do is then just start implementing. And then, so the first part I'm gonna implement is just this base case, so that way I don't end up with a really long recursive problem. So is leaf and then t, because that's what we're passing in, and then return. And then what do I need my height to be? That is a question. So it depends on how I connect the other input, what I'm adding to them. If I think of a tree and I only have one node, I'd probably say that the height is, I don't know, like 1 or something, because it has one level, it's one node. So I'm just gonna return a 1. And then down here, for recursive call, I can either just say else, or I could just ignore that, because if I return here, then the code below is never gonna execute anyways. So it doesn't really matter if you want to do else or just go for the rest of the solution. I like doing else because I can visually see how that works. So I have else. Then I'm just gonna say b in branches for t, and then I would like to return the height of then b. And so this is what I have so far. And so now I would like to figure out, let's see, we would like to return the longest branch of all the branch heights. So I need to keep them together. Let's see, I think I could try a list. So maybe I could say like, let's see, all heights or something maybe. And then these brackets to mark as a list, and then go ahead and we'll append that. Okay, so this will give me the height. I don't know if this is exactly what I want yet. I think this is on its way. So I have this list, and then I want to end up returning the longest. So probably, let's see, I think it's max. Yeah, all heights. And here. Okay, and then I'll just space out so the codes look easier to read. I have a hard time reading when all the code's all squashed up together, so I create blocks like this. And then this shouldn't be, let's just see what this does. So to check that, let's see, I think what I'm gonna do is I'm gonna put a print statement or something. Yeah, I'll say debug, and then let's go ahead and I would like to see what's being added to the list as I go so far. So I'm gonna say, yeah, debug, and then I'm gonna take this list, and then I want to look at the last item it just appended, and I can do that with the -1 index. And that will give me whatever the last element was. And then I'm gonna save that. Let's go ahead and run. Oh, I clicked on the wrong key. And then it looks like I did forget something. I did forget to call this a string. Okay. So we have debug 1, 1, 1, and then we got a 1. So in this example, we have node 3. We have this 5, 1, and then 2. So it looks like 5 is a child of 3, and then 2 is a child of 3, then 1 is a 5. Okay. So let's see. I guess I can go back to my drawing spot. Okay. We have 3, and then And then we have, see, I think there's a comma there, so then we have 2. So we have 5 to the left of 3, then 2 to the right of 3, and then it looks like then 5 also has then this piece here of being C tree 1. Okay, yeah, and then the height. So the expected, if I, looking at the code, if we, it looks like this would be considered a height of 2. Okay, so it doesn't count that top node. Okay, so that means that if we just have a leaf, then that means the height is actually going to be 0. And so we're only counting, I guess, levels of children, which is why we would get a height of 2. So let's go back to the code and fix that. Okay, we have return, so we'll return 0, okay. And then let's go ahead, I'll save that, run this. Okay, now I get a bunch of zeros. Okay, so what I'm getting is that every time I'm at a leaf, I go down, all the way down, yeah, like that 1 at the very bottom, and then I'm returning a 0, and then that's all I'm doing. So, and then I go into then the other branch of 3, which is 2, that's a leaf, so return a 0, and then that's all we're doing. Okay. So then so to connect that means if I do go into a branch, I do want to add a 1 for that specific branch. So I'm gonna do that. So I'm gonna say height B, and then I'm gonna add a 1, because every time I look at some branch path, I can add a 1 here, because all these heights is going to be, the length of this is going to be for however many branches. So if I have branch 1, branch 2, branch 3, dot, 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 these numbers are going to be the height of those specific paths that are coming off of the very first node. And so if I do a 1, that will allow me to go all the way down to the bottom to look at 1, and so then we'll get a 0, then we'll come here, return a 1, and then we'll come back, and then we'll be at node 5, then we will add a 1 to that height, so now we have 2, and then go back again, and so we're at the start, so now we have 2, and so then we can pen those, and pen that 2, and then go to the next branch, which will then be tree 2, which only has 1, so it will come give a 0, but then I'll add a 1 here, and then it will add that 1. So let's see what happens if I run it. So now I get 1, then I get 2, and I believe that 2 we get this first one when we hit node 1, tree 1, yeah, here. And then we get debug 2 when we come back out after tree 5. And then we get debug 1 when we then hop over from the for loop into this branch 2. And then the maximum of then those two number values will then be 2. So I think we now have a working solution here. So let's go ahead and try this test case. Okay, save. And then this time I got 3, and it did want a 3.